Today we're going to be talking about electron configuration. What is electron configuration? Electron configuration is a representation of electrons distributed between the orbital shells and subshells. Electron configuration of an atom can be used to determine where on the periodic table the atom falls. Subshells and sublevels. Sublevels all contain orbitals. Electrons occupy different sublevels. Sublevel S has one orbital and electron capacity of 2. Sublevel P has 3 orbitals and an electron capacity of 6. Sublevel D has 5 orbitals and an electron capacity of 10. Sublevel F has 7 orbitals and an electron capacity of 14. As seen in the picture to the right, if we start at the bottom at 1s, there's 1 orbital which 2 electrons can fit in. If we proceed up to 2s, there's also 1 orbital where 2 electrons are also able to fit. If we go slightly to the right, we see 2p, which is the p orbital, which has 3 orbitals that has a capacity of 6. If we proceed up, we can see that the diagram follows the sublevel with the number of orbitals and the electron capacity. Orbitals. Orbitals all have 2 electrons. There are 4 different types of orbitals: the s block, the p block, the d block, and the f block. Let's practice. What is the electron configuration of oxygen? So first, we're going to identify where oxygen is on the periodic table. It is element 8, and it is in the p block. Next, we're going to start with hydrogen, and we're going to work our way through. So starting with hydrogen, we see that the 1s orbital is full, which means that 1s2 is the first part of the electron configuration. We then going to proceed to group 2, and we know that 2s, that orbital is also filled. We then proceed to the 2p group, and that is where we're able to see that oxygen is the 4th element in that block, leading us to know that the electron configuration is 1s2, 2s2, and 2p4. If we look at where oxygen is on the periodic table, it is in the 2nd group and in the p block. It is the 4th element in the 2p group. Electron configuration for ions. When we have an ion like O2-, then the electron configuration will be different. We have to take into account the addition of 2 more electrons. Oxygen has 8 electrons. Oxygen 2- has 10 electrons. We add the 8 that oxygen originally has with the 2 that were added on. This gives us the 10. We already identified on the last slide that oxygen has an electron configuration of 1s2, 2s2, and 2p4. When adding 2 more electrons, the electron configuration would change and be 1s2, 2s2, and 2p6. In addition, when you have an ion like aluminum 3+, you take into account the loss of 3 electrons. Aluminum has 13 electrons. Aluminum 3+ has 10 electrons. This time, we subtract 3 from the number of electrons that aluminum has regularly. Aluminum has an electron configuration of 1s2, 2s2, 2p6, 3s2, and 3p1. When subtracting 3 electrons, we get the electron configuration of 1s2, 2s2, and 2p6. Although both ions, oxygen and aluminum, have the same electron configuration, this does not mean that they are now the same element. nor are they the same element as neon, which is the one that has 1s2, 2s2, and 2p6 as the ground state electron configuration. Noble gas notation. Using the noble gas notation, you can write a more condensed electron configuration. Let's do an example. Using the noble gas notation, write the electron configuration for chlorine. The regular electron configuration for chlorine is 1s2, 2s2, 2p6, 3s2, and 3p5. Chlorine is the 17th element. We're going to look backwards and we see that neon is the last noble gas before chlorine. We're going to start with sodium to write this electron configuration. So we write neon in brackets since that's the last noble gas, and then we start at sodium with 3s2 and then proceed to 3p5. We stop at 3p5 because chlorine is the 5th element in the third group and in the p block.